What? How does radar not be possible? What does that get thrown in for?
Well, for radar, we emit a pulse and we expect a return at some point. The amount of time between the emission and the reception tells us how far away the object is that the pulse bounced off of. So we can use time to tell us how far away something is. We can use aberration to tell us how much something has differed from its apparent position.
So if you're speaking about like bouncing radar off of like celestial objects, I would have a bit of a contention about it. If you're talking about radar like bounced like the military uses or an aircraft would use per se and like shoot radar out, those are two objects in which you have an actual location, right? What you're speaking about is an apparent location, right? Not an actual location. And the only way to get that actual location, again, I've said it many times, stated in the sentence which you said agreed with, is to measure it from the inertial frame of the sun. So unless you can explain how to do that, what you have is a calculation from a non-actual apparent position that you think you know the true position, but you have no way to confirm it.
Okay, that's not what that sentence says. It doesn't say you have to measure it from the inertial reference frame of the sun.
Yeah, it clearly does. It says as measured. It was already done. As measured. The true position as measured in the inertial frame of the sun. Yes, sir.
Okay, you're forgetting the rest of the sentence.
No, I'm not. I mean, you were just clearly ignoring the end, which is, the damning part for you.
Okay, the rest of the sentence describes the process that I described, which is we use the aberration and the apparent position to know where the true position is.
Correct. Like I said, you're using a non-actual apparent position to calculate what you think is the true position, but you could never know the true position because you would need to measure it again from the inertial frame of the sun.
But the aberration tells us what the difference is, doesn't it?
It tells you what you think it is, right? Again, what you think it is. You don't have a way to verify.
Okay, aberration tells us something is moving, correct? This is fucking basic, man.
Okay.
Yeah, and we could be moving is the point. Or like, I'm sorry, forgive me, the stars could be moving, not necessarily us.
Okay, I wasn't making that argument.
No, we are. That's the implication of what he's saying, is that your point can't be substantiated and it doesn't refute our point that the stars might be moving. That's why, hence, what I initially said was we both have religious beliefs and it's okay.
The point of stellar aberration in a single object is not to determine whether the Earth is moving or not. The point of stellar aberration in a single object, in the context of Hammer's bringing up this point, is to determine where the true position of it is. And that's what I'm talking about.
So wait a minute. You just said the point of stellar aberration is not to determine if the Earth is moving?
I made a very specific statement. You're leaving out some words. Why would you do that?
Again, I'm trying to get it clarified. That's what I got from your sentence. So clarify if I'm incorrect. I'm not trying to strawman you, sir.
Okay, what I said was the point of stellar aberration for a single celestial object is not to determine which thing is moving. It's to determine where the thing's true position is from its apparent position.
But correct me if I'm wrong here. You have been using it. You said aberration, something is moving, correct? Aberration tells us that something is moving. Is that not the sentence you've been repeating?
Yep.
And you haven't been inferring to the surface of the Earth with that.
Not with just stellar aberration on the observation of a single object.
That is very sneaky.
Excuse me?
Sneaky.
It's specific. Being specific about your position is not sneaky. When I say, if we look at one object and we see aberration, we can't know which thing is moving, I'm being entirely
What's moving,
correct.
bro?
However,
Which one's moving?
when we combine the rest of the celestial sphere that we observe and notice the aberration follows a particular pattern, and that pattern involves the Earth's annual, or the sun's annual position relative to us, then we know Which one is moving? I know you want to interrupt it, but just go ahead, I guess. Fuck off.
Then you can infer that we're moving? Is
If
that the
if
bada bing?
the entire universe that we observe, all of the lights that we see, which, as you guys said, must come from some kind of matter, then what we see is that the motion of all of these things would show us that the Earth is moving around the sun.
Is stellar aberration apparent or actual?
Everything that you see when you make the observation is apparent.
Hey.
So not actual.
That's not how that works. If I see my car is in the parking lot, I say, well, apparently my car is in the parking lot. Does that mean the car is not in the parking lot?
No, you see your car in the parking lot, your car is in the parking lot. You see something celestial that you can never validate or confirm, it's apparent. That's the difference.
Okay, everything that you make an observation of as it appears to you, because that's where the word apparent fucking comes from. When you see something and that's how it appears to you, it is by definition apparent to you.
No, that's not how that works. So for
Yes,
example, when
that's
you
how the
see the
English
sun,
language works.
yeah, you don't need to interrupt me now. You were done, thank you. So when you see the sun, right? The sun is in its apparent location, i.e., not its actual location. You understand that?
Okay, what definition of apparent are you using to say that apparent must mean not actual?
I guess you're just not following. Is the sun where we see it in its actual location? Yes or no?
Depends on which direction you're looking.
So you're just not going to be honest.
That's the fucking answer. If I'm looking
That's
at
not the
zenith,
answer.
yes, it is. If I'm looking at zenith to the sun, if I'm at the subsolar point, then the direction of the sun is in that direction. Its apparent and actual direction are the same.
So you're
However,
saying it has
if
to be
I'm
in its.
looking in any other direction, atmospheric refraction will move that sun by a little bit.
So when you're talking in regards to stellar aberration, are you looking at its zenith or are you looking at some other angle?
Obviously, by the time anybody is trying to figure out the positions of things, they are taking atmospheric refraction into account.
So not actual. Got it.
Jesus Christ, dude. So if I see the sun at zenith, that's where it appears to me. That's its apparent position. What happens to be the case is that that's also its actual position.
You cut out, but that's fine. I get the point. I understand how refraction works at zenith, but that wasn't the question. I know that's what you want to bring it to drive your point home, but that's irrelevant to the context of the conversation.
Okay, well, when I look up the definition of apparent, it's where something appears to be, or how it appears to you. That's what the definition is. If you want to say
Yeah,
that something is in its actual position and its apparent position, but it's not apparent for some reason, that would be a wonderful argument for you to make.
didn't make that argument, but
Or you want
I
to.
appreciate you pointing out the distinction that stellar aberration is not actual; it's apparent.
Every observation that you make, as it appears to you, everything is apparent.
Yeah,
Apparently.
apparently, right?
Okay? So what I would need from you is, since you seem to be so set on the idea that apparent means that not actual, that's in the definition somewhere, I'd like you to post that definition.
Yeah, I'm driving right now. No, I'm not doing Google searches for you, man. I think everybody's understood on the difference between actual and apparent.
It's
Do you
just
want to?
Everybody that's got a dictionary in front of them disagrees with you, so
Do you acknowledge the
stuff.
non-apparentness of the situation, or like what's going
who acknowledges what? What are we acknowledging?
on? Who knows, mate?
Well, yeah,
Hey,
isn't
man.
the sun like not really where we see it at?
Welcome to
Apparently.
the conversation, Isa.
Yeah.
It depends on which way you're looking. I just said this moments ago.
What if you're just looking
No, it
up?
doesn't depend on which way you're looking. Let's be a little more specific. Any other direction other than the zenith of the celestial object will be its apparent location.
It's not the zenith as a special object, it's your zenith.
Doofus, have you ever seen the sun down? Like, below? Have you ever
Have
seen
I
the
ever
sun
seen
below?
the sun down below?
Right. No. Yeah?
As far as I got was, have you ever seen the sun down below? What was the rest of it?
Since you've been born, like the moment you woke up to this moment, very moment we're having this discussion now, it's always been above your horizon, right?
Okay, that's a wonderful assertion. I have no idea why you just said that.
It's just above you, okay? It's always just above you.
Brilliant. That would be great if you brought something to support that statement.
It's apparent, okay? Clearly apparent. It's above you.
Wonderful.
Hey, Rick, have you ever just thought Earth could be a globe, man?
Be a lot easier.
I used to think that. Not so
This
much these days. It's getting a
this
bit
could be the
wild, I'll
first-
tell you that much, okay?
First time
You
someone
guys
said
with
a
your
real
wacky
fact.
ideas.
Well, okay, how about this? If we're going to talk about, or at least I'm going to talk about it, if we're going to talk about what's easier, all we had to do to address stellar aberration was just say the Earth's in motion, and that that's the observation that we have. If we wanted to go to flat Earth, now we have to say it's sonoluminescence, but it operates in a way that we've never seen sonoluminescence operate before. Now we have to come up with some additional physics that nobody's ever heard of. We just got to keep adding these things that are more and more complicated in order to fit the observation.
Dude, you think that the sun is a hydrogen nuclear fusion reactor exploding for 4 freaking billion years, maybe more,
Yeah,
13 billion, I don't know, whatever the figure is. You think that we're ridiculous in our propositions, and that's your premise.
It's not a reactor.
It's just, it's
a
kind of
reaction.
so fantastical in its notion that you don't recognize the irony with which you put the proposition forward. You're coming to us with it.
Yeah, the
It's
emission
crazy,
spectra
dude.
from the
Wake
sun.
the fuck
The
up,
emission
man.
spectra from the sun includes hydrogen and helium, and the processes involved there are observable directly using spectroscopy. So, who's crazy now?
Go for it, man. Spectroscopy can solve all your problems.
Spectroscopy?
Like,
Well,
You want
yo,
an
isn't
honest answer to that?
spectroscopy what made and that's what made a bitch out of Hubble, because he was like, in order to avoid the horror of a fixed position, we're gonna use spectroscopy, right? It's kind of like a cope.
No, the statement was not based on
Yeah,
spectroscopy.
it is. It is though. That's his. It was a hard. Like, you guys don't entertain the other position because it's so scary. It's a religious opinion you have.
Okay, Hubble's statement was not based on spectroscopy. It was based on redshift and blueshift.
What the fuck is spectroscopy, bro?
Looking at looking at individual spectras, individual emissions from a particular object.
okay, great. So where's
Is
all
it
the
not?
hydrogen?
Who here has any idea what the fuck is going on? Who knows what spectroscopy is?
I'm following along, Doofus. I'm following along.
You're
I'm
trying
getting
to say
trolled a little bit.
the makeup of stars using light, right?
Using colours.
Yeah, using the specific emission spectra.
Gotcha.
Nothing to do with
What
the
you
fixed position or geocentrism.
Yeah, who's changing topics now? Let's go.
Well, that was my faux pas.
No, that's good fun.
You're jumping between different scripts.
So where's the hydrogen go? Like, right? Like, where does all the hydrogen go, do you think? It goes
becomes
up, right? 'Cause it's very light. Yeah, and then you're looking up in the sky and you're seeing this big ball of and it's emitting this certain light form, right? And it's coming down. All the hydrogen should be up there, right? You're just saying that it's a big
Brownian
bubble in the
motion
sky
exists?
full of hydrogen that's exploding within a fusion reactor in the space, that's creating a gravity well, which creates the solar system. Like, that's
Doesn't
a whole
it burn
different
up
other
and
paradigm,
light
isn't it?
created?
Yeah, you're skipping a whole lot of different observations in order to draw that absurdity that you said, which is not what we
Yeah,
say.
exactly. It
Hold
draws
on a
out the
second. Hey,
insanity
Don,
of the
Don,
position.
when you hear people talking, don't interrupt.
what our
Don.
argument is, if you make up a different argument for
You
us
hear me trying
that
to
we
mod?
don't say, then it's called a straw man, right?
Doofus, you hear me trying to mod? Don, If you want to get in, dude. But try not to go when people are talking, bro. You have a tendency to do that shit.
Okay, I hear you. I think everyone does it a bit. Yeah, thanks.
Yep.
Mainly you, Don. Mainly you. But let's work on it. All right. Thanks.
Where are we?
So it
You
burns
creating
off.
something.
Spectroscopium.
Spectroscopy.
Oh god, it's the guy who doesn't know where the cardinal directions are.
You know, like, where's all the hydrogen go? Up there?
I've got the answer.
And then you're saying that you
listen.
see. Okay, yep.
It burns off and goes away.
It goes bye bye.
So you think that, like, okay, so the element that you think that the sun is made of, right, just so happens to float really high up in the sky within our sort of earthly sort of paradigm, within the heliocentric model. And, like, all I'm doing in your supposition is that I'm conflating the two. Like, you've taken the thing that is the lightest thing that happens to go up and said that it happens to be in a big ball of flame 9.3 million miles away or whatever it is.
No, we're saying we
Yeah.
saw a
Why
big
don't you just address
flame.
what he said, though, Risky? When you
I'm
say
gonna-
Which part?
hydrogen goes away, it just disappears, Don? Is that what you're saying? What's the byproduct of hydrogen, Don?
I don't know the specifics, but the point isn't that it has to go somewhere. The point is that it goes somewhere naturally, and that's fine.
That's fine.
Yeah,
Of
but in a
course.
closed loop system, the hydrogen would collect at the top of the system,
It's not a
right?
closed loop. The universe model is not a closed loop. It's a huge empty void.
So you say.
That's what they
Yeah,
say.
Doofus. Thanks for pointing out that fact. Don says hydrogen burns up. So yes, what that would mean there's a byproduct of hydrogen, would it not? Or does it just completely vaporize and disappear from Cartesianal existence? You want to
Did
answer
you
that,
ask him?
Doofus, or you want to let Don?
Yeah, did you ask him what he meant by go away? Because you immediately turned it to burning.
I mean, isn't that what the sun is doing?
Is it on fire?
I mean, is it not?
No, it is not on fire.
I mean,
Oh,
I probably
how so?
used the wrong language. I meant there's a reaction, yeah, and then it spreads out, changes. That's kind of what I was trying to mean.
Okay, so
Everything that has combustion.
it spreads out. That's what you're saying, Don?
Yeah, whether it spreads out or it burns off or it disappears or it changes, I think my point was Rick shouldn't be worried about where it's going. It just controls itself. It's fine.
I mean, I guess Rick doesn't have a brain.
That's too good. All right. So what were you saying, Doofus, about a reaction versus burning or whatever you wanted to get on about?
Not all things that release energy on their combustion have byproducts.
Huh?
Such as,
Well, in this particular case, hydrogen.
okay, so you have an example of that here, that in a lab setting?
Okay, get some hydrogen gas, light it on fire. What happened?
So I'm asking you,
Jesus, man.
what do you mean, Jesus? Why do you got to turn to God to fill the gaps?
So we could actually Google this. I can ask ChatGPT what happens to the chemicals in the sun, where do they go, and it'll tell me, and then I'll tell Rick, and he won't be happy anyway.
Well, we were talking about this with Fundy earlier on today. It's like, isn't it so funny that you can take up a stick and you can get it to compulsively start turning into light? Just ignite it. Fusion reaction, plasma. Starts turning, like, the stick, the carbon apparently wants to turn into light, whether it be thermal radiation or light itself, as we perceive it.
A stick burning is not fusion.
Plasma, whatever.
Yeah, whatever, I guess.
You all right, Doofus? You sound like a little cranky.
I'm enjoying the company of people that are saying things that they don't know what's actually going on.
Yeah, this is Doofus enjoying himself.
Presuming he knows what's going on.
Well, presumably, if I mention spectroscopy and then somebody mentions Hubble, I probably know what's going on a little bit.
Oh, yeah.
Let me ask you, Rick. where,
So is a
where
stick
does the
made of like condensated light?
okay.
Tell me that. Like,
What is this stick
so,
thing? Can you explain stick thing?
well, why does the stick want to turn into light? Why does the stick turn into
Who
light?
said
Like,
that?
what's
Hey,
going
real
on
quick,
there?
can I just address something real quick? Because I feel like there was a slant made, and I just had to look up. Is the Doppler effect a part of spectroscopy? Yes, the Doppler effect is considered part of spectroscopy. Spectroscopy. So when you're trying to like poo-poo me bringing Hubble into spectroscopy, who sounds retarded?
The statement that you referred to specifically referred to redshift and blue shift.
Yeah, well, I mean, regardless though, it's still it was in the ballpark. Is my point, man. Don't make fun of me, dude. especially,
Doesn't
especially
Hubble
with you and your
Hubble
magical
is
sky daddy of
Yeah,
gravity over there.
it was. We managed to link
Hubble
it.
what?
I'm saying ISA was just in the ballpark. We managed to link it. It's fine.
Yeah.
Rick.
So what about a stick?
Yeah, who says sticks can turn into light? I don't understand what that means.
Sticks turn into light, bro.
We'll ignore all the other things that have to happen in order for that to occur.
No, just ignition. It wants to turn into light. Once you set that fire on, material. It would seem that a lot of materials
Oh
actually
right.
want to become light for some reason. I'm even coming up with the idea like right now. There's like basically these trees are just gathering light. They're just building themselves through light. That's what the tree is. It's a light being like
My God.
caused like built into the material. Well, what do you think it is, dude?
No,
Like
no, no. I
seriously.
mean,
Oh,
just chill
it's
down.
sucking in carbon through its like
Just chill out.
pores.
It
Like it's
loves light.
breathing in carbon and it just constructs it. It's like, oh yeah, that's
Yeah,
such a
yeah, yeah.
like that's such a
It
more reasonable position to take.
no, I'm
It
just saying
is
it's
if
not
you
just
measure the
light.
amount of carbon dioxide before and after the reaction, which is you get less carbon dioxide and more O2.
Air and water trees like. Of course they like light. Light's very important.
Yeah, it's the energy
So
source needed for the reaction.
why does it want to burst into light all of a sudden when it becomes dead? Apparently,
Yeah, why does
why
combustion
does it want to
waste
become
energy? Well, let's think on that one for a moment.
hit it?
I mean,
Pretty
you
sure
got to
they
start.
discovered a bacteria recently that uses light like a plant. It's photosynthesizes light
It's not
to
recent.
produce its. Well, it was fairly recent.
What?
I believe
When
you.
was it discovered?
Some mushrooms
I mean,
like the dark.
there's
Some
animal
might look
cells with
light.
chloroplasts in them. I mean, that's not new.
Okay, so I'm saying when was it discovered if it's not fairly recent?
Okay, we're gonna hinge on what the definition of recent.
You might have seen the science recently. That's fair enough.
No, I mean as far as I'm aware, this was a recently discovered thing. It's kind of unique in the sense that it's not a plant yet still uses
Yeah,
photosynthesis.
I'll
So
give
I
you a
don't know. I
few.
mean, just give me a ballpark figure. Was it like 20 years ago, Doofus? 10 years ago? What do you think?
Repeat the discovery one more time. What, in brief, what happened with
Yeah,
photosynthesis?
it's a base. I'm pretty sure it was a bacteria that uses photosynthesis.
All right, I'm looking at one example right now, dated 1870.
Okay, so then maybe I'm thinking of something else. Let me see here. Maybe it was
No,
an algae or a bug.
they would have said in the science article, just found out, unique phenomenon. That's how they write it.
It does say that they've recently published some stuff
Okay, yeah,
discovering an understanding of photosynthesis in bacteria. 2024 revealed that blah blah blah.
There you go.
Purple sulfur bacteria can photosynthesize even low calcium environments. So they're continuing to research it to this day and discovering more.
and they've also found an
But
aphid
there's
that did
animal
a
cells with
similar thing.
chloroplasts in them that were discovered in 1870. So
Maybe I was thinking of this aphid. I don't know. They also discovered a bug that uses photosynthesis.
If I
So yeah,
if I cared to be racist, I could say humans use the sun to evolve. So we use photosynthesis?
Well said, Dawn. Well said.
Okay, thanks.
Oh yeah, so trees apparently want to turn into light if you just light them on fire. Okay,
Yeah, let's
that's
stick
my
on
premise.
Let's stick on the Rick,
Tell me I'm wrong. Okay,
you're generally
yeah, a lot
confused
of things
about
want to turn into light.
chemical reactions and especially fires, and you want to know more.
No, I don't know. Like you can light metals on fire, given the right
Space.
proportion ratio of oxygen to like material.
Okay.
Aluminum sets on fire really well.
We can think of the sun as a space fireball, and then talk about how it's a bit different to a fireball.
Well, it's electroplasmatic sort of ejection.
In the way that it's
Inventing physics time.
in the way that it's not a fireball at all.
Yeah.
No,
it's an electrical phenomenon.
To help Rick understand more about it, we can pretend it's like a fireball. That's what the ancients thought, right? This is just this bright thing. It must be a ball of fire.
It's interesting, right? The ancients actually sort of conceived of it in several different ways. One of them actually was a point where it was actually like it seems to be depicted. I went looking up for this. It's depicted as a lump of sort of logs and trees or something that set ignite. So there's depictions of that. The next one was ether, which I'm sure you globe guys are really not like that. Like it's the pure emission of ether was the next one. And then in more recent, like modern times, its interpretation is that of a nuclear reactor. So nuclear fusion reaction sort of interpretation of what the sun is. So it would seem to me that the thing in the sky, like through civilizational interpretation, is concurrent with its technological sort of interpretation. That's the way I would interpret it at the moment, anyway.
Okay, yeah. So what was the three? Ether. What else?
Basically, just a big log burning firewood, like a coal in the sky. Essentially, was the proposition. I've seen illustrations of it put forward. And then obviously we live in the paradigm now of what is it, Einsteinian nuclear reaction fusion, Oppenheimian sort of propositions of the way that nuclear reactions occur, and that's just the interpretation they have of the sun in the sky.
Yeah, the more we look at something, the more we learn about it.
You know, if you
that's
learn
not necessarily true, right?
Okay, well, we had a problem with spectroscopy, apparently.
Yes, you do.
Yeah, you definitely do.
You can learn about the real sun on heliocentricity, then apply that to a flat Earth to scale it down. Then you know what the sun is.
No, the phenomenon is completely different, I would say.
Nah, the sun's not a nuclear reactor. It's an atom being split by gravity. So it's a hydrogen atom that got split and turned into helium and was a sun. Now it's a big hydrogen bomb fart. It's okay.